We're doing fine. Ngayon, we will discuss about sets and its basic concepts. So, ito yung lesson sa mga grade 7 learners ngayon. And this is also part of sets and functions and mapping series ko. So, let's proceed. So, ano yung mga objectives natin ngayon? So, number 1, we should know that what is a set and its basic concepts. Number 2, we should have the basic knowledge that what is a universal set, complement, intersection, a disjoint, and a union of a set. And we will discover it through visualization. So, what do you see in this picture? So, before we start. So, as we can see here, may nakita tayo na group of objects, or group of shapes rather, that may rectangle tayo, may square, may triangle, and other regular and irregular shapes. So, anong tawag natin dito? Okay. We can say that this collection of shapes is a set. But why? Why we call it this a set? Because a set is basically the group of objects. For example, a group of blocks. I mean, the set of blocks, the set of school supplies, right? Okay, number 2. While the shapes inside the circle, we can call them elements. So each member or the shape can be called an element or in plural form, elements. Okay, number 1. So since we know what is a set looks like, so we can go to the definition of a set. Okay, so a set is a collection of objects, and within the collection, the objects are called elements. So the elements are basically the members of the set, and a set is a collection of objects or a group of objects. Okay, number 2. A set can be infinite or finite collection of objects. So here are the examples of finite and infinite set. So the finite set looks like this, and an infinite set looks like this. Basically, the difference between the two is that the infinite set has these 3 dots at the end, while the finite set doesn't have that 3 dots. So another example of infinite set is, for example, real numbers, because they are infinite members of real numbers. So okay, so let's proceed. A set is written in 2 ways or notations and forms. Example. Okay, this is the example of roster notation. So basically, the roster notation is you just need to list the elements within this bracket or within this parenthesis. That is roster notation. And letter B, we have set builder notation. So it looks like this. So if we want to read it, we can read it in this way. It is the set of all x such that 1 is less than or equal to x, but x is less than or equal to 7. Okay, so if you ask me, so if you want to know kung paano siya ma-convert each notation to one another, so let's see kung paano siya i-convert. Okay, so for example, we have a set written in roster notation. So we want it to be converted into a set builder notation. So paano natin siya gagawin? Okay, so let any element in set A be x. So or any variable you want. So kung gusto mo ang first letter ng name mo or first letter ng crush mo, it's up to you. For me, it's x muna. Okay, so since 1 is the first element and 5 is the last element we saw, so we have a clue. Okay, so tignan natin kung paano siya ginagawa. Okay, wait. Okay. So as we can see here, look at this these forms. Okay, so we have this number 1. So if we can read that, we say that the set of all x such that 0 is less than x. Okay, why I put 0? Because it is less than 1. So you could put 0. You could also put 1 if you want. As long as just look at the difference between the two. Okay, so let's proceed. So less than x, but also x is less than 6. So we know that 6 is more than 5, and we know that 5 is less than 6. That's why ganito yung tsura niya. So, or 2, the set of all x such that x is greater than or equal to 1. Okay, so mas madali maintindihan yung number 2 kasi makikita talaga natin yung one of the elements dito. So, you can pause this video for a while and you will see the difference. Okay? So, I will not explain it further because I just want you to analyze. I want you to think. What do you think of this notation? Okay? Okay, so number 2, so how we convert from a set um, builder notation into a roster notation. So we have this. So this is an example of a set builder notation. Okay, so the set of all x such that x is a whole number. Okay, so we know that whole numbers has no end. So if we list them all, that would be yeah. So that's why it looks like this, because we know that the whole number, it has infinite numbers. So we start from 0 because 0 is also a whole number, so it looks like this. So note that this is also an infinite set because we have infinite whole numbers. So here are the basic concepts. Okay, so number 2, repetition and order does not matter for sets. So whenever you do, for example, if you arrange this way and this way, they are just the same set. While if you want to list the set in this way, like yx, x, 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 and yx, though these are just the same set as well. So they're just the same, regardless of order or repetition, it doesn't matter at all. Okay, so number 3, so we have different kinds of set relationships or operations such as subsets, complements, union, intersection, disjoint, set difference, and a universal set. Okay, so we will go through to this. So we will go through more in this operations. Okay. Okay, so number 3, lastly, if a set contains no elements, then we can write it in this way. Okay, just pause the video for a while if you want to. And this is the, so as you can see here, the bracket has no elements, so that's why ito yung itsura niya. While ito naman, this is the other way naman, how to say that a set has no element at all. Okay. Okay, example of a subset. Okay, so what do you see in this picture? So as we can see here, we have the bigger set B. So and we have the smaller A. So as we can see here, the set A is inside the set B. So we can say that set A is the subset of set B. Okay. So, number 1, a subset is part of one big set. So, yan nakikita natin. So, number 2, a subset set A is like the daughter set of the parent set. So, parang ito yung magulang niya, tapos ito yung anak. So, ang anak nasa loob ng magulang. Ito yan siya. Okay. So, other details that we can get from the picture. Okay. In defining a subset, we can write it in this way. So, A, so how to read this? So, which means set A is a subset of set B, or set B contains set A. Okay. So number 2, a subset contains some elements of its parent set. So because we see that the subset is smaller than the set, and the subset is inside the parent set rather. Okay, example. So this is the subset. We have subset A, 1, 2, 3, and we have subset parent set, which is set B. So as we can see here, we have common elements. So 1, 2, 3, these are the elements of set A, also B has also 1, 2, 3 in its set. So therefore, we can say that set A is the subset of set B. Okay, so we will proceed to set operations, and this is also the set theory. Okay. Okay, so what is this? This is an example of a universal set. So, so as we can see, we have this box or the rectangular box, and within this rectangular box, we have three different circles or sets. Okay, so let U be the universal set. Okay, so let's make an example here. So set U is a set of whole numbers. So A has 1, 2, 3. So B has 4, 5, 6. And C is 10, 11, and 16. Okay. Okay, you can pause this video for a while. Okay. So what are the big ideas we can get from the picture? Okay. Number one, sets A, B, and C are the subset of set U, which is the universal set. Okay. So basically, the universal set is just like a relationship of a set and a subset. So, but the difference is that the outside the universal set, there are no elements. So, from the word universal, so it means kung ano nasa loob ng universal set, yun lang ang na-consider. Okay. So, ito yung sinasabi ko. So, outside of set U, no elements nor other sets can be found. So, you cannot see a set here. So, outside of the universal set. Okay, let's proceed. So, other insights that we can get from the picture. So, number one, a universal set is a set that all elements in it are considered. Apart from the universal set, there are no elements found. So, outside the box, there are no objects. That's the analogy between the universal set and a box. Okay, so this is an example of a complement of a set. So ano nakikita nyo dito? Okay, example. So let U be the universal set, and U are the whole numbers up to 10. So A1 is 1, 5, 6, 7, or A dash or A raised to C, ito is 2, 3, 4, 8, 9, 10. So okay, so you can pause this video for a while and see and analyze. What do you think? Okay. So here are the big ideas we can get from the picture. Okay, number one, a complement of a set contains elements that are in the universal set except in set A. So basically, the complement of set A has the elements that cannot be found in set A but can be found at set U. So for example, another example, so if the universal set is the set of all foods, if set A contains fast food, so in complement of set A, it contains healthy food. So meaning, so it implies that the complement of set A has elements that are in set U, but we cannot find it in set A. Okay, so other insights we can get from the picture. Okay, in defining a complement, we can write in this way. Okay, set with the notation. So we will use it. So, okay, the complement of a set. Okay, the set of all x that such x can be found at set U, but or n x cannot be found in set A. So where U is a universal set. So it means that in the complement of set A, we can find these elements inside of set U, but we cannot find it in set A. Okay. Okay, so this is an example of the intersection of two sets. Okay, example. Okay, so we have A and B. So A, okay, you can just pause that. Okay, so let's see. Okay, so as we can see here, so this intersection of two sets is just a Venn diagram basically. So meaning, okay, so basically we just need to find the the common elements that are both in A and B. So okay, let's use this examples. Okay, so in set A we have glass, cup, laptop, pencil, and cell phone. While in set B we have glass, cell phone, bag, shovel, and pillow. So basically we will just find the common elements that are in A and B. So you have glass, we have cell phone. And this is the answer. So when we read it, it reads as the intersection of A and B. So this is the intersection. Okay, insights that we can get from the picture. Okay, so we know that intersection of sets are just basically finding the common elements, just like I said, that we can find in both sets A and B. Therefore, we can write it in this way. Sorry for the typo error. Okay, so set A, so the intersection of set A and B, it is the set of all x such that x can be found at in A and in B. Union siya. Okay, let's proceed to another. So this is the union of two sets. Here you go. Okay, though it looks like a Venn diagram, but if the intersection is just finding all the common elements in A and B, this time union is you just need to combine the elements. So we will merge these two sets into one set, and that is the union of two sets. Okay, example. We have A, glass, cup, laptop, pencil, cell phone, and B, glass, cell phone, bag, and shovel, and pillow. So basically, the union of two sets, we just need to merge these two sets into this one. So you can pause this video for a while and you can see the pattern. Okay. So as we can see here, the shaded color is the same. So it means A and B are unified. Okay, that's basically the meaning of union of the sets. So insights we can get from the picture. Okay, a union is the combination of sets A and B, meaning we can find elements that are in A or in B. So therefore, we can write in this way in set builder notation. Okay, so the union of sets A and B is the set of all x such that x can be found in A or in B. So kung sa intersection is and, ngayon naman sa union is or. Okay? Okay. So this is an example of disjoint of two sets. So in the previous examples, we can see talaga that A and B are joined together, but this time the disjoint they are separated. Oh, so sad. Yeah, hindi sila tinatadhana. Sayang naman. Okay. So, insights. So, sets A and B are distinct. So, yan yung makikita natin. Though they are in the same universal set, but still, they are separated. Sayang. So, the two sets have nothing in common. They have no intersection, nor they are united. So, walang union. They're just completely separated. Though they're the same space, but nah. So here's an example of a set difference. Okay. So example, we have A, we have B. So A is glass, bag, laptop, pencil, cell phone, while B is we have glass, cell phone, bag, shovel, and pillow. So I just bold it. So okay. Okay, so basically the set difference, we just need to slash down lang natin yung mga common elements that we can found both in A and B. So we have glass, bag, and cell phone. So ano na naiwan na lang dito? So we have laptop, pencil, shovel, and pillow. And therefore, the set difference of A and B is laptop, shovel, pencil, and pillow. Yun siya. Okay? Okay, insights of we can get from the picture. Okay, a set difference is a set where you can find elements of set A that you cannot find in set B. Okay, so last one, we have the cardinality of a set. Sorry. Okay, so the cardinality of a set refers to the size of a set by counting all of its elements. Okay, so examples, we have this one. So one, so we have only one element. So this is the form of the cardinality of a set. So therefore the cardinality of this set is 1. Okay, so as we can see here, we have two elements, so therefore the cardinality of this set is 2. So if we count it, is 1 and 2, and that's the cardinality. Okay, so cardinality is basically the number of elements in each set. So we have this one, so 1, 4, 5, 6. Okay, so the cardinality of this is 4 because we have 4 elements that we can find in this set C. Okay, so how about this one? So we can see here we have 4 elements, but letter Y is repeated 4 times, but as we know that repetition does not matter in sets. So still we have the cardinality of this set is equal to 1 because this then regardless of all repetitions, it's just still equal to 1 element. That's why it's 1. Okay. Okay, so how to determine the number of subsets in each set? To determine the number of subsets in each set, we can do it through enumeration, and most of all using two important equations, which we will discuss it later. Okay, for enumeration. Okay, so let A be 1, 2, 3, 4. Okay, so total of subsets, the number of subsets is 16. Well, I know it's really many. I cannot believe that. Okay, so anyway, so list of subsets. So we have this and this and this and this. So you just need to take the the elements on each, so like this one. So you can pause this video for a while and you will really see the pattern behind this one. Okay, and this one. So what I did is that I just take the elements and make being a subset, so I just make subsets that we can, so the elements of the subsets that can be found in this set. So yeah, and by the way, do you know that the set itself is also the subset of itself? This one, this is actually a subset. Yeah, and this also is also a subset, even though it has no elements. That's why there are 16 subsets. Okay, so using the equation, so we have this one. So by computation, so 2 raised to n, where n is the number of elements of a set. So 2 raised to 4 is equal to 16 subsets. So 2 times 2 is equal to 4, times 2 is equal to 8, times 2 is equal to 16. That's why we have 16 subsets. So what is the meaning of proper subset? So the proper subset, it excludes the set itself, because as we can see in the previous slide, the set itself is also the subset. Okay, so the number of proper subsets is this. So the number of subsets minus 1, so 16 minus 1 is equal to 15 proper subsets. Okay, so other laws and set properties in this of the set of sets. So we have the De Morgan's law and other set properties. So in this slide, probably I will have a feature video about this one, but if you want it, just comment down below, or it depends on my time. But I hope that you learned something. So yeah, so this is the end of this video. Okay, so thank you for watching and bye bye for now.